Hello friends, today we will go through the compaction and consolidations associated with the soil mechanics subject, and we will discuss about the various differences between compaction and consolidations. Furthermore, we will go through the certain factors affecting compaction and consolidation of soil. So let us start. So this compaction is the artificial process that is employed for increasing the density or the unit density of the soil, and it is required for the construction of earthen dams, canal embankments, highways, etc. In compaction, there is the pressing of soil particles close to each other by the mechanical means, and in this compaction air is expelled out from the void space and increases in the mass density takes place. It is done for increasing the various engineering properties of the soil particles, and it has to increase the shear strength of soil and hence increases the stability of the soil and the bearing capacity of the soil particles or bearing capacity of the soil. So let us discuss about the factors affecting compaction of soil. First is the water content. This is the very important factor that is affecting the compaction of soil. Now this is the curve between the dry density of soil and the water content, in which there are two results of the test, that is from the standard Proctor test, first graph, and another is modified Proctor test, and OMC is called optimum moisture content. Here at low water content, soil is steep and soil grains offer more resistance to compaction. As the water content increases, water films are formed around the soil grains, and water around the soil grains act as the lubricating agent. Due to this, soil grains come close to each other and makes a dense configuration. At optimum moisture content, that is OMC, soil reaches the maximum unit weight, as lubrication effect is the maximum at this stage. Further addition of more water replaces the soil grains. Thus, addition of more water after optimum moisture content reduces the unit weight, as unit weight of water is less than the unit weight of the soil grains. Second factor is the amount of compacting effort. So this maximum dry unit weight increases with the increase in the compactive effort. Now increase in the compactive effort decreases the optimum moisture content to some extent. If a soil is already moist, weaker and above optimum moisture content, then applying more energy is wasteful, since air can easily or quickly be removed. Applying large amount of energy to a very moist soil may be damaging, since no more soil can be expelled but high pore water pressure can build up. Third factor affecting compaction is type of soil. So in general, coarse grained soil can be compacted to higher density than the fine grained soil. A well graded sand attains a much higher density than the poorly graded soil. Cohesive soil requires more water than the cohesionless soil, and optimum moisture content is high in the cohesive soil. Fourth is the method of compaction. So it is observed that the mode of compaction influences the shape of the compaction curve. The shape of the compaction curve for standard Proctor test and modified Proctor test are somewhat different. The shape of the compaction curve obtained from laboratory test and obtained from the field by various compactive methods are also different. So fifth is the type of compactor, that is the compacting equipment. So on the basis of which equipment we use for compaction, this can also affect the compaction of the soil. So on the basis of soil type, we can use different compacting equipments. Like for crushed rock or gravel sand, we can use smooth wheel rollers, and for sand, gravel, silty soil, clay soils, we can use pneumatic tire rollers, and for silty soils and clay soils, sheep foot rollers, can be used, and rammer can be used in case of soil confined in spaces. Now we shall discuss about consolidations. So this consolidation is the gradual process of reduction in volume under sustained static loading. Consolidation takes place by reduction in the volume of a saturated soil due to squeezing out of water from the soil, and it is the natural process occurring in the saturated soil subjected to static loading by the weight of the building and other structure, etc. So these are the various defects or failures that is caused due to the consolidation of soil in the subsequent ground layers. Now we shall discuss about the compactions and consolidations differences. Okay, so this compaction is the expulsion of pore air, whereas consolidation is the expulsion of pore water. Now compaction applies to cohesive as well as cohesionless soil, but this consolidation is mainly applied to the cohesive soil. Compaction is brought about by artificial or human agencies, but this consolidation is brought about by application of load or by natural agencies. Compaction occurs due to dynamic loading, and this consolidation is mainly occurred due to the static loading. Compaction relatively is a quick process, but this consolidation is the process involving a slow process. Okay, so consolidation is the slow process. So this is the difference between compaction and consolidation. You can see that in compaction the main difference is there is the reduction in the volume of air, and in consolidations there is the reduction in the volume of water.